For some time now, I've been calculating base flood elevations for the National Flood Insurance Program, and now have a new project where I want to share that knowledge and how it's done with other floodplain managers. So that's what this is. Basically, I want to introduce that and show some of the neat tools that are available for doing that and how it's done. I think a lot of it can be automated and made easier through the new GIS portals that are so prevalent now. And this is an example of one of those. And this is actually shows the National Flood Hazard Layer produced by FEMA that's part of the NFIP program. The NFIP program is made up of a mapping program or mapping effort that shows risk, a 1% annual risk of flooding over the areas in the country where communities have decided to participate in the program. So that's what this is about. It's about basically calculating those BFEs and how it's done. The areas where these things, where BFEs are calculated, are zone A's. And what I'm doing right now is trying to find one of those zones, because these areas right here with the lines across them are considered detailed study areas in our zone AEs. The E means elevation. Well, the areas designated as zone A's do not have elevations. So that's what we're trying to do, is to determine an elevation for these areas like this. And that's what I'm going to be trying to show over a period of time with these spontaneous type of YouTubes that I publish on this channel. It started with evaluating and getting calls in my job, and it led me to this manual, which is published by FEMA. And you can see how old this is. It hasn't been updated. But basically, I took this manual and evaluated it for creating a GIS process. And here's what it says about this. The guide was developed for community officials, property owners, developers, surveyors, and engineers who may need to determine base 100-year flood elevations, BFEs, in a special flood hazard area designated as approximate zone A. And the real emphasis is to do it at minimal cost. So that's what makes this so important, because there's a lot of ways to do this that end up being very costly. But following this manual, you should be able to do it at a minimal cost. And it shows here where this can be done and put some limitations on it. Riverine areas, lake areas where flow conditions are uniform. And it's not to be used in areas with alluvial fan flooding or characteristics of alluvial fan. And those types of areas are basically when the drainage comes out of the watershed. It's usually higher at the headwaters and lower at the bottom of the watershed. But the bottom of the watershed is where alluvial fan is. It's where a lot of the debris and runoff drags deposits into the lower portion of the watershed. It also says here that you shouldn't do it in the coastal regions. So there are some things to know and limitations to where these can be done. But where I typically do them, these, and where zone A's are, those aren't usually issues. Because the coastal zones are actually designated as something other than zone A. And zone A's are typically in areas of less habitation. And most of the time, the urban areas that we populate seem to be all in the alluvial fan areas. So those don't seem to be issues. So here's the introduction. Local community officials in administrating and enforcing the floodplain management requirements of the National Flood Insurance Program. That's who this is intended for. So it's intended for helping local officials manage the floodplain and to do it in a cost-effective way. Although BFEs are not provided, the community is still responsible for ensuring that new development within proximate Zone A areas is constructed using methods that will minimize flood damages. Usually new construction where I've been taking calls isn't the issue. It's where you have pre-firm buildings that are affected by the flood maps and people are trying to reduce their insurance. So that's also what makes this very important. Included in this guide are methodologies that can be used to develop BFEs, and which can be used to determine the elevation or floodproofing requirements for buildings. So this is a great book. I mean, even though it's pretty old, it says it was like 1995, it still has great methods of how to manage the floodplain. A little bit more information. A lot of communities have designated areas and accepted these maps. FEMA only provides BFEs for the floodplains of those flooding sources that are currently subject to development pressure or are projected at initiation of a flood insurance study or flood insurance study restudy. So what that means is they don't have detailed studies everywhere, even though the BFE is a requirement in the management of the program. So this method was developed to, fix that problem within the program. As a result, most communities will have firms that include special flood hazard areas for flooding sources that have been studied in detail, and other areas that have been studied using approximate methods and have been designated as approximate zone A's. But here's the advantages of developing BFE data, which we're going to try to do, and which I'm going to try to convey how to do. Minimize and reduce future flood losses, lower insurance rates, so less burden will be placed on our permitting officials. Sizable community rating system credits are available for community rating system communities that develop BFEs. And it's possible that property can be removed from the floodplain by issuance of a letter of map amendment or letter of map revision. So that's a big deal. And those are significant benefits. And I think everybody would like to see some more of those types of benefits. So here's what makes what I'm going to show you a detailed method, because of these three factors. So there's methods that are not detailed, which can be used to indicate where people can build. But the idea of a detailed method here is it really benefits existing homes that are affected by the floodplain designated as a Zone A, because the hazard can be measured and it can actually be used to reduce your flood insurance and possibly remove from the floodplain. And here is the reason why, and here is the reasons why this is a detailed method. It's because it uses geometry of a cross section of the floodplain. Now I'm going to show you how to do it using a DEM and a GIS system. Hydrology for the particular location, and this is stream flow. So I'm going to show you how we use the NSS program that's available from USGS to determine this. And then there's the hydraulics And hydraulics involves the determination of the water surface elevation. And this manual actually goes along with a program that is no longer being maintained called Quick 2. So we're using Quick 2 to develop that. And there's also more discussion on this, but I'm not going to go through this book, but I will put it down in the bottom here of this link in this video so that you can use it and see it for reference, because it is very important. But here's the concepts that we're going to be running through. And this is actually a demonstration that can be found up on the FEMA's portal. So it's pretty nice and it's pretty easy to go through, and it tells you the information in a better pictorial way than the book. So it talks about some more technical information. This is where they're talking about the topology, the hydrology, and the hydraulics. A little bit more detail of what it means in the topography. But like I said, what we've done is taken it from these concepts that are basically 1995 and changed it into a GIS-based system. So a lot of the things that they're discussing in here, and most of these things could be automated and are being automated right now. Most of the mapping program, as we've seen previously, has been automated and digitized. This is showing an example of a location of a zone A. Here's a single property location, which is usually what we deal with all the time in floodplain management. And here it just says, okay, they're going to use discharge of 536, but I'm going to show us how to get that discharge. Calculating slope, simple mathematical equations, where to place cross sections and how to do cross sections. Only one is needed on a single property. And this is showing basically what happens when and if, because you could hire a surveyor to do this too. But in this case, I'm going to show how it's done from a DEM. So it's an automated process. When you place the line, there's steps you can do to extract this same type of information. Channel banks, very easy. Manning's in values, we're going to use land cover that's been downloaded from USGS, and that has been determined through various studies and studies by professionals to determine these Manning's in values from land cover. And then we're going to learn how to use Quick 2. Quick 2, the way I use it is a DOS program. None of the programs work well because they're on older systems, but I use the DOS program, and I'll show it to you here in a minute. This is actually version 2. With what I wanted to do with automating processes, actually the version 1 was better. The computations are the same. The only difference is the interface. And that's the end. But I'll put a link to this program down the bottom also for reference. So what I want to do is use freeware mostly, so that there's no issues with people who want to do this not having the resources to do it. So one of the major things I'm going to do is use QGIS. And while that's loading, I'll see if this workbook here will load, because the spreadsheet I use is also in freeware, which in this case is OpenOffice. And you know, when I'm doing these and which sometimes goes for a long time without doing them. This just brings back and kind of leads me through the process. And here's a lot of the same things that we've already talked about and references to them. So we fill in square miles, elevations, measure distances, slope, in a spreadsheet is a formula which calculates it. We'll show you how to retrieve the Manning's N values from land cover information. We'll use the National Stream Statistics Program to document the region and actually to determine the peak flow of what they used to call the 100-year, but which is now the 1% annual chance flood. And then we'll put all this information into Quick2 to determine the BFE, or base flood elevation. I've got a pretty good start going here. So I actually use ArcMap at work, but wanted to make this so that more people could use it. So that's when I decided to start converting a lot of the processes to the open source, and I haven't had a problem doing that. We'll be using it. DEMs, and I'll show you where to download those and how to use them in this process. And a lot of the layers I use are national level data sets, but the DEM does not lend itself to a national level data set because of the accuracy needed. You need to have an accuracy better or equal to the existing floodplain map. So that's something that you need to look into and be aware of. And in most cases, in this area that I work in the state that I'm typically do this research for, that's not an issue. And most of the times, this elevation data is being updated and continuously improved by USGS. Some of the other USGS information that we use on there is, where'd it go? One of the things I'll be showing you is this REST service layer that comes from USGS. Very nice layer that shows the topography and the hydrology. Does a really good job at pulling a lot of information together. And in a GIS system, one of the benefits of it, and when they're set up properly, is when you zoom in and out, it shows more detail and less detail at the different scales that you're working at. But we're going to be looking at West Virginia. And if I look at a county level, it'll be Cabell County. Here's some of the national levels that help when we're doing this. These are flow lines, so this is all the stream data. And like I mentioned before, a lot of these layers are from USGS, and they actually go into the preparation of this USGS topography that I downloaded. And this is a REST service for use with over-the-internet GIS layers, like I showed you in the beginning. But a lot of times, and most times, it's nice to have the local files. And that's what this is. There's places on the internet where you can download this information, and it's very useful in having that local when you're working on a GIS system and something technical of this nature, something that you have to reference, all the time or have available. This is actually the national land cover data, and this is for 2011, and it's been done for West Virginia. Oh, come on, be quick. I don't like the weight on it. So if you look at this, what this does is it designates what this MN is on the end is that's the Manning's N values that have been designated based on the land cover values. And this was research that's been done, and it can be found on the internet. When I started doing this, where I found it was actually in a FEMA flood insurance study, which they call an FIS study. It had properties of land cover and then their associated values. So in a GIS system, you're able to click on these layers, and here, this would be the Manning's N value. So when we're looking at an area or a location to determine Manning's N values, we can determine it very quickly. This has water body information. That's what this is. The USGS does a phenomenal job of collecting this type of information for the country and for the nation. It's amazing what they do. I'm a big fan of USGS. And this is actually a national level, what they call flood accumulation, or FAC is what they abbreviated, and it stands for, at least in my mind, flood accumulation grid. And what makes this so nice is in areas where you have, or an area of interest, you can quickly identify how big the watershed is. So if I click on one of these cells that are lighter colored, oh, that's not the right one. So if I click on one of these cells that are lighter colored, it shows me how many square miles. So this is initially done in meters, but what I've done on this one is calculated and changed it and used a raster calculator inside of this GIS system to change it to square miles. So now when I click on an area that is close to the cross section where we're interested in on the stream, it gives me a area in square miles of the watershed that drains into this. Very useful, very useful. We also have what they call catchments. This is another national layer data. And this one I've actually clipped it to the state that I'm interested in. But this is another way to measure area, because one of the things that I've done in this layer is to calculate each one of those as square miles. So now I know how many square miles each one of these layers are. So in conjunction with the flow line, you can designate and look up areas and have alternate methods of checking for how many square miles are in a watershed at your project location, because that's like the first thing you need. The first thing that you're interested in is determining how big a watershed drains to that point. And that's what makes this, one of the things that makes this a detailed study is it has, the three things that we discussed. It has channel geometry, hydrology, and hydraulics. But what it doesn't have that a detailed study has is a flow regime. This is assuming that, the whole drainage area is putting the drainage on a specific point on that we will designate as the cross section, and all the drainage from the watershed is going to be at that point at no specific time. In mapping, when they're doing detailed studies, that flow has a regime, of time and as it moves. Not in this case. So even though this meets minimum requirements, it typically is a little bit higher. The risk associated is measured using these minimum requirements is generally a little bit higher. But what it does do is make it affordable, because the map studies are very expensive and require a lot of data collection. Here's another interesting layer, and let me see if it'll let me show you at the state level. But this is a study. This is a study from USGS where they've actually evaluated discharges. And this is where I want to shift to some of the other programs that support calculating the BFE, because this is one of them. This is a report that USGS did, and I actually pulled this map out of the report and geo-referenced it, in this case, with the state. And it breaks the state up into areas: Eastern, Central, and Western. So what we use that in is this program right here called NSS, National Stream Statistics. So here I am in our state. I'm going to hit a new calculation for a project. And here's where this comes and is used, because you have to know which region it's in. You have to know the national region, which in our case is 4 on the national map, right here. And then in a state region, which could be any one of these 3, I'm going to select Western. And then you put this drainage in square miles in this field. You select this Crippen and Blue flood region. And then you know, and what we end up calculating is based on this report, which is also referenced here. And it's available out on the internet. And it goes into way more detail than either of us know. So let's put a number in here. We'll say 1 square mile. And this is what it calculates. And it gives you a report. And here is what we're interested in, the PK100, which in this case is 557. Peak 100 or peak 1% annual chance, based on these values here and the 1 square mile drainage basin. So that's what we'll be calculating, and that's where we get it from. In this case, 557. So mark that down right here, 557. First thing. And then for your records, in which I want to emphasize good record keeping, what I do is to just capture this, put it in record. Bam. I don't like that. I wanted the window. Huh. Well, I guess it saw it. Just did the whole screen. Oh well. I don't have to do, except that I'd probably do it this way. File, save as, put it in your records. In the same way that's done, this is quick too, and this is what I use to calculate hydraulics. I use it in DOSBOX. It's very fast, very simple, and I'll show you how I automate that, because I don't show it in here, but I usually take a spreadsheet, turn some of this off, do a cross section, copy to clipboard, paste it here, it's very crude, just meant to show a lot of how easy it is, although it's very technical. And once that's done, I trim it down to 40 points, because that's all that Quick2 will accept. I create a formula over here that formats a text file, that will bring it directly into this program. So you start with a normal depth 3, you do an irregular channel, I, and this is it. And the text file I have as example is already in there. Oh shoot, that's that. You have to retrieve it. You have to hit F6. So this is just a quick one I did. Just, it's not even real. Slope 0.002. Begin calculations. That's how easy it is. And this right here is the water surface elevation, and it gives you a flow type. And it builds in some error checking too, which is really nice. And it's mentioned in that book that we reviewed in the beginning, FEMA Managing Zone A's. In this case, it says subcritical. Most of this flow type is based on the slope. So if it's real steep, sometimes it can become critical. So in that case, let's go back to the main menu, F7. You would use number 1 and recalculate it. And in this case, since we already have the file made and the information made, we just pull it right back in again and calculate it again because it's a different formula. So none of this is really that hard. It's a lot of steps. But once you do it, let's say 100 times, it's fairly easy. So that's what I want to share. That's what I want to share with floodplain managers and all those people that were identified and as part of the manual, what it was designed for right here. You know, I just don't see a property owner doing this, but this is actually probably a good book to look at. It is written to be simplified and to, you know, expose this technology and this process to a lot of different people. So it would be good to look at. I'm just not sure that it is pretty technical. You know, most of the time people that deal with numbers, this is who they are, surveyors and engineers. And that's who I would see doing this. And maybe somebody like myself who has a geography degree and works in GIS, or somebody who is familiar enough with, comfortable with the GIS enough to go through this process. And that's what I'm wanting to work on, is if we have people out there that can do this GIS process, I think we can expose and provide more BFEs, you know, to the people that need it in these areas. What areas are those? These are them. All these red counties in this depiction have flood maps. And you know, I haven't looked at all of them, but I know the ones that I look at a lot in this area have zone A's. And there's a lot of people that work on this, and it doesn't hurt, and it wouldn't hurt to have a few more. So that's what I want to do. But in any case, I want to try to make them quick. I want to try to make them, you know, to guide people along. So that's all I have for now. Catch you next time.